In this video, we're going to talk about 2.1.1 set fundamentals, and specifically the standard that we're going to talk about here is represent a set using set builder notation. In this problem, it says use set builder notation to express the set of squares of integers between 1 and 1,000 exclusively, i.e. not including 1 and 1,000. So to start this problem, let's just figure out how to read set builder notation. So each one of these is set builder notation. So to start, we need to define that this bracket means that we have a set. So we would start by saying we would start by saying, let's start with the set of all n cubed. So we read this bracket and we say the set, and then we say of all n cubed, because n cubed is our function there, our expression. So the set of all n cubed, and then this line right here, this vertical line, means such that. So we're going to say such that. So this is the vertical line. I'm just going to draw that here. Vertical line there. Such that n is an element. So this E here, this weird looking E means is an element of the, now I'm going to write these up here. So this is talking about a certain set of numbers, and they define the natural numbers as being n, the whole numbers as being w, integer numbers as z, rationals as q, reals as r, and imaginary as I. So this is when you're reading math notation, this is how they're going to represent these classes of numbers. So we've got z here, so we're talking about the integers. So we're going to say n is an element of the integers, and n squared is between 1 and 1,000, and because it says greater than 1 and less than 1,000, we can say that that's exclusively. So that's how you would read the set builder notation. Again, the bracket says that we have a set, the n cubed, so the set of all n cubed, and then this line, vertical line here, means such that n is an element of the integers, so n is an element of the integers, and n squared is between 1 and 1,000 exclusively. Now, let's go back to what they were asking us originally in the problem. They said, use set builder notation to express the set of squares of integers between 1 and 1,000 exclusively, i.e. not including 1 and 1,000. And they're saying the set of squares. Well, we know for a set of squares, right, we're taking the same number times itself. So that would be like x squared. So we can rule out n cubed right away. We're going to be looking at just n squared. And then when we square numbers, we have to figure out like what's the largest number that we can square and still be within 1,000. So notice that all of these are referring to n. They're referring to n because if I took 1,000 and I squared it, I'd have 1,000,000. So that would be outside of our range of 1 and 1,000. This is always talking about the ending value. So we're going to let's take 32 and square it and see what 32 squared would be. So 32 squared is 1,024. Now it says less than 32, so technically I can't really get to 32 squared. 32 squared would be 1,024, right? So that's actually above 1,000, but I can't even use 32 because it says n has to be less than 32. So let's look at 31 squared then, right? And if you look at the bottom one, you can't reach 31 of this bottom one. So this one, the largest number is actually going to be 30. So this one here, the largest number is 31. So we're going to do 31 times itself, and we had 961. So technically, this option right here would make sure that our n squared value is between 1 and 1,000, because n would have to be no bigger than 31 here, because n is a member of the integer family. So 31 squared gives you 961. That's still within 1,000, so this would be our correct set builder notation for the square of integers between 1 and 1,000 exclusively, i.e. not including 1 and 1,000. Okay, let's do a second example. We'll do the one just below. It says, which of the following uses set builder notation to denote the set of all negative integers? So if we want all negative integers, then we're going to look for x being less than 0. That would give us all negative integers. So first of all, we can rule out that this is a real number, right? This is talking about real numbers, whereas these are talking about integers. So then we just have to pick the correct one. So this one would be x less than 0. This is our correct solution in set builder notation. We'd read that the set of all x such that, or we'd say we have a set where x is an element of the integers such that x is less than 0. So that's talking about the negative integers. Let's try another problem. It says, use set builder notation to express a set of all positive even integers strictly greater than 100. So they want all the even integers greater than 100, strictly greater than 100. So they want x greater than 100. Well, we only have two of those possibilities here. We have, it could either be this one or this one, because this is x less than 50 and x greater than 50. So we got to rule those out. And they were talking about even integers, so we need to make sure that we have integers for both of these two options, and they both have integers there. Now, which one's going to give us the even numbers? Well, the one that will give us the even numbers is actually the 2x piece. We have x and we have 2x. Well, x is going to go through and it's going to be 101, 102, 103, 104, so on and so forth. Whereas this one here would be, I just caught myself here. This one would actually be, if I used 101 here, I would get 202. And then I use 102 here and I get 204. Well, it says greater than 100. So this, I was wrong on these two options. These two options actually give you numbers greater than 200 for, well, this one here specifically will give you numbers greater than 200. This one will give you numbers greater than 100, but it's going to give you every single number. It's going to give you 101, 102, 103. And they want positive even integers strictly greater than 100. So we actually need to look at 50, because 50 times 2 gives you the 100. And then that would make us greater than 100. So let's think about this. 51 times the 2 would give you 102. 52 times the 2 would give you 104. And now we're starting to get 53 times the 2 gives you 106. Now we're getting all those even positive integers strictly above 100. So this would be the correct solution there. So you kind of got to watch out with this x greater than 100, x less than 50. You got to watch out for how they're restricting you here based on your problem, because we were going to have to use 2x here, so we're going to have to multiply this number. Let's look at one more example. Which of the following uses set builder notation to denote the set of integers that are greater than or equal to negative 10 and less than or equal to 10? So greater than or equal to negative 10 and less than or equal to 10. So we need to have, it's going to be either this one or this one, because both of these are greater than negative 10 and less than 10. Or I should say this one's greater than 10, less than 10. This one is greater than negative 10 and less than or equal to 10. We need them to both be greater than or equal to negative 10 and less than or equal to 10. That's these two options here. Now, which one would work here? So it says they're both integers, so that's good. This one says we're greater than or equal to negative 10. This one says we're less than or equal to 10, which is what they're asking for here. So that would be the top option. Now, what's the difference between the top option and the bottom option? Well, the bottom option, the second option. The second option says greater than or equal to 10 and less than or equal to negative 10. So this one wouldn't work at all.